Hello, today I'm going to teach you about binomial random variables. So binomial means that there are two possible outcomes. For instance, imagine flipping a coin. There is the outcome of heads and there's the outcome of tails. There are two outcomes and there's always going to be a set probability of each outcome. P is the probability of success, so in flipping a coin it would be 0.5 or 50%. So now let's think about how are we going to go about doing calculations for binomial probability distributions. So first off, our conditions need to be satisfied. The conditions can be represented by the acronym BINS. So B is binomial, it has to have two possible outcomes. I is independent, trials can't affect each other. So knowing the result of, say, the first trial shouldn't affect your knowledge of what will happen in the second trial. It has to be a fixed number of trials, which we usually denote as N, and there has to be a fixed probability of success that doesn't change. So now, as far as performing inference goes, we can say the probability that the number of successes equals, the set value, which we abbreviate as K. It'll be this variable, which we don't need to focus on right now. The probability of success to the power of the number of successes, and then times 1 minus the probability of success to the probability of failure, then to the power of n minus k, which is basically the number of trials that are failures. So it's basically the probability of getting this many successes times the probability of getting this many failures times this constant. Now this constant, you might have heard before, it called sort of n choose k, or nck, and it basically refers to the general amount of possible ways that a certain event can occur. So if you have a group of 3 people and you have one success in that group of 3 people, person number 1 could be the success, person number 2 could be the success, or person number 3 could be the success. So here's an example. So you have a question, yes or no, right? Let's suppose there's just some random probability of success and probability of failure, one of yes, one of no. It satisfies our conditions, it's independent, and the probability doesn't change over time. So what's this nck going to be, right? Well, you could have the first statement be yes and the other ones be no, or you could have the second statement be yes, or the third statement be a yes. So that leaves 3 possibilities, so nck is going to be 3. Now you can calculate this using this formula for more hard problems, more difficult problems. And it's n factorial, which, remember, if n is like 4, it would be 4 times 3 times 2 times 1 divided by k factorial times n minus k factorial. So the number of trials factorial times the number of successes factorial times the number of failures factorial. Now, a tip is, instead of doing this whole long process for this formula, just use binomial CDF on your calculator, and that'll really help you on the AP test to save time. And if you really feel uncomfortable and you have a lot of extra time on the AP test, you could go about maybe using this method to try to figure out what nck actually is. But I would recommend using the calculator for the sake of time. And you can use binomial PDF if, for instance, they're asking you what's the probability that x is less than a certain number. So p x is less than 3, let's say. And that'll also save you some time. So now, if you want to do sort of normal inference on the binomial distribution, for sample means, you can use NP for the mean, and for standard deviation, the square root of NP times 1 minus P. And similarly for proportions, the proportion is going to be the actual probability of success, P, and the standard deviation, square root of P times 1 minus P over N. Now remember, this is not a geometric distribution. A geometric distribution is something entirely different. It's a probability of success. How many trials are you going to need to do to get a success once, which is not what this is at all. So on the AP test, don't make this common mistake. Don't mistake a binomial distribution for a geometric distribution, and on your calculator, make sure you say binom CDF and not geometric CDF. So now if you want more practice, you can look at the AP question FRQ 2011 number 3 on Form B. So this is how you get to the binom CDF on your calculator. So you first have to press distribution, you press second, then distribution. You get this. You scroll down to binom CDF. You press enter. The trials, let's say there's 5 trials. The probability of success is 0.5, and we want 1 success. And then we paste it in. And this is CDF, not PDF, so this is actually not we want 1%. It's we want 1 or less successes, so 0 or 1. And that's the probability that we get. Alright, thank you.